So within the Esrim plan, we generally identify those areas that may be needing some work, looking at how things are connected, of course. We always have principles on where we start within a landscape, what we need to do within landscapes, but that's kind of the map we can draw up for each individual area, identifying techniques and strategies that might be useful to rehabilitate that area, some waypoints on where to do it, and then obviously some on-ground advice on how to go about implementing those on-ground activities. Of course, the most effective way to minimise erosion in any sort of landscape is to maximise the level of ground cover you have. That leads me to the next point, which is managing animals and how best to do it. Again, probably not like this. We've already talked quite a bit about grazing, so I'm going to really try and quickly get through this, but there's essentially no contradiction between how you manage landscapes for carbon and grazing. You've got your options of, well, let's start at the top there. The majority of carbon, we've already said, is stored in woody material as shrubs and trees. Now, generally, cattle and sheep don't like to eat wood, so you're fairly safe on grazing within woody vegetation. However, you do need to think about that ecological functioning again. So you don't want an unhealthy system. You're not necessarily going to lose a lot of your woody vegetation, but you still want the system to be functioning. Soil carbon, on the other hand, requires really healthy soil functioning, and that requires a lot more biomass across the area and a lot more ground cover. So if you're looking to work in a soil carbon field, grazing management becomes a lot more important. So there's two potential strategies I see. There's either total exclusion of grazing, or there's strategic grazing with a rest-based grazing system. If you are managing grazing within the same area, or if you are planning on grazing an area that you're also managing for carbon, some of the general points are, as we've already said, a short, infrequent, heavy graze, removing all non-domestic grazing as much as possible through various techniques there. The three benefits of grazing within a carbon farming area are that if managing appropriately, it can enhance the landscape function. It is a useful tool to reduce fire loads, and it can provide a significant supplementary income from an area. But there's a major risk, and that is that if it's managed inappropriately, you can quickly degrade what current carbon stores you have and any future sequestration rates through the reduced landscape function. And a couple of photos there we've already, Sam's already brought up about the improved perennial grass root systems based on that rest-based grazing system. So again, within Esrim, we look at your grazing management, we look at it as a holistic plan, and we identify areas that you might be able to use for different grazing strategies, be they conservation and culture, carbon, rotational grazing. We look at carrying capacity, stocking rates and grazing systems. So it's kind of, again, tying it all in. We've identified areas for erosion control. We're looking at station-wide grazing management and the different strategies that can be employed within those different areas. Finally, fire. Very quickly, carbon farming requires minimal fire. Generally in mulga shrubland we say fire should be excluded until such time as the fuel load within the area makes wildfire a major risk. Of course, grazing might minimise that, at which time a cool winter burn may be effective to refresh vegetation. In the eucalypt woodland, I'm using these two examples because they're generally where carbon is stored in vegetation, in that woody shrubland and woodland. So again, spin effects underneath, we recommend a cool winter burn every 5 to 7 years in a 10,000 hectare mosaic. Tussock grassland fire should really be excluded and managed similarly to mulga. I believe grazing should be used in tussock grassland because it's making more use of the pasture than if it just goes up in smoke. But if you're not grazing it, then let it get to the point where it's becoming a real wildfire risk and then maybe burn it off a bit. But you've got to have control over your area before you can even start to implement any of these strategies. And again, that comes through to the broader landscape management question of how things work in between. So you might look at getting a mosaic burning pattern, putting some fire sacrifice areas around your carbon farming area, or implementing some fire breaks. And again, within Esrim, we go through all of that with you, and we identify some, in this case, a mosaic burning pattern that could be implemented on a station, where we identify particular fire management zones, put in a rotation, and map it out according to your landscape. So I'll leave it there, and I've probably rushed.
Thank you very much. It's good to hear the fire and the fauna talked about, because we haven't covered those as much, so it's good to see them there. Thank you so much. We now have our penultimate talk, and this is the potential for sequestration through land restoration. And our speaker is PJ, Peter-Jon, but he's always PJ, he assures me, Waddell. And over the past 20 years has worked and travelled extensively through rangeland environments. Work commenced in the rangelands with a mineral exploration company based at Leonora. In the year 2000, he joined the WA Department of Agriculture as a Resource Management and Protection Officer in Kalgoorlie. When seconded to the Centre for the Management of Arid Environments as a landscape ecologist, PJ was involved in trialling rangeland rehabilitation treatments for the Ecosystem Management Understanding, the EMU project. Since 2006, continued developing understanding of the landscape ecology through management with the Department of Agriculture and Food's Rangeland Survey project. A Bachelor of Science with honours in biology and a Master's in geology from Curtin Uni. We welcome you, PJ, to share your insights with us.
Thanks, Lynn. Thanks, Pew, for inviting us to speak. There will be a little bit of overlap here with Richard, because he's covered some restoration processes that I'll be looking to get. So this talk will be covering a little bit about the science behind land system mapping, because Peter Russell and I mentioned have talked about land systems, and property plans are based on those land system maps. Then I'll be moving into explaining through the topographic sequence, the Katina sequence, landscape function, and the restoration treatments issues to use in those to address the landscape processes.
Using that topographic Katina sequence,
I'll be explaining some of the key drivers
hills, ranges,
affect
breakaways,
landscape function and degradation, because I think by explaining
ponding
them,
banks have worked
it
successfully
helps
here.
explain why we're choosing some of these restoration
Scale of the
treatments.
problem is quite extensive in the southern rangelands.
So
ponding banks
to
work by retaining water.
manage a
not
landscape,
damming
you
it.
have to understand the
It's
patterns
holding
and
it back.
processes within
If we
it.
retain water, then we
And
can
land system
accumulate
mapping helps us
sediment,
do that,
accumulating
and that's
sediment,
the basis for
capture the nutrients,
any sort of
and
restoration
regrow your plants,
and property
improve
planning
the soil
exercise.
moisture balance.
With a land system,
Here's a photo
in
of where
mapping
ponding
them, we
banks have been
describe
on
all
the
the
station
components
30
within
years.
the system.
Um,
That is
before and after photos.
landforms, soils and
The one on
vegetation.
the top left shows the
A land
channel,
system
which
by
is
definition is
unchanged.
an area or group of
Spike
areas
grazing
with
and
reoccurring patterns
grazing strategies of
in
de-stocking,
landform,
nothing happens
soils,
until they hit the
vegetation.
ponding bank.
And
Ponding bank allows sediment to
to describe
accumulate.
these or map them,
and then
we
the
use
grass will
detailed
grow.
image analysis that starts off
In
with
this same
aerial
landscape,
photography.
this is what the ponding
Looking
banks
for those
look like
patterns,
when we introduced
and then we
grass
have
and
other
put
data
grass
sets
over the
to
top.
help
So
us
the
use
banks
that,
are
such as
stabilised,
digital
quite
elevation
functional,
models,
productive landscape
radiometrics, which looks at isotope signals of
In the shrublands,
potassium,
we've been trialling ponding
uranium,
banks.
thorium,
In this example, you can
and
see
we have Landsat
top left that
satellite
drainage
imagery
line
to help us on top of that,
that
and
is
then we
highly
get our
eroded.
patterns
Before you
mapped
can
up,
go in there and
that's
fix
the
that
maps we
drainage
use.
line, we've got to slow down the flow up.
Across
slope.
most of the
That's what
lands
these
under
ponding
pastoralist
banks are
tenure, we
attempting
have
to do.
land system maps
And after
available.
one
There's
thing
two
to show
areas
the ponding
remaining,
banks is
which
the
the
next
southern Gulf
exponential
area in the pink,
effect.
which is being mapped at the
Usually
moment,
takes about 8 to 10
and there's
years
the lunar
for the
survey,
soil to start
may
conditioning
or may
itself.
not go ahead.
Then you get a sort of, by about the 15-year mark, you
The
start
topographic
to see a
Katina
good
sequence
response to plant growth.
is basically
So they are a slow
a soil
investment,
profile moving down
but
the
you've got to
slope.
get that conditioning process
Look at the
happening. So here
land
it's
systems,
only just
how they're
ticking over
linked
the
in a
10-year
network,
period, and we're starting to see
functional
stabilisation of the
units.
banks.
So if we look at your upland
Slowing
slopes,
the water flow through that area.
made up of
This
hills
slide
and
here
ranges,
shows an interesting story
moving down
in that
through your
ponding
transfer
banks
zones of
were
sheep
installed without a
bush
grazing strategy.
into your
For 15
alluvial
years after they
plains,
were installed,
bottom
they became
lands,
a preferential
and
grazing
floodplains.
habitat for goats.
across all these
The ephemeral
dysfunctional
water that
systems
sat
that
there
have
for the banks was a great
landscape
source of water
processes
for them, and
occurring,
colonising
and
plants
then
that
you have
try to grow
degradation across all of them that affect each one.
It's only in the last
compounding
10
as you
years
move
with
down.
these wild dogs
So
controlling
restoration treatments
the
typically
goat
have to start
population, that those
upslope.
banks have really taken off.
To start
One
down the
thing that did
bottom,
happen
you're
in
getting
that
maximum
period was
water
sediment
wash
wasn't
straight through them,
accumulating.
and
You
the
can see by the photos on the left.
structure that you
The lag
is likely to
surface
be
when that
blown
first
out.
put in 91.
So the drivers
Now,
of
a lot of
degradation
the
tend to be
covered up.
pastoralists today are left
Sediment.
trying to manage the historic legacy
Within these
of
upland
overgrazing.
environments, you
So
have
the
drainage
pre-war
channels.
two stocking rates
Again,
have just
water is
completely
moving
stripped
through your
away the
landscape
country.
and
Perennial
spilling through your natural
plant
drainage lines.
species have been lost, grassland
Say what
have been
Lynn
lost.
said earlier, we can
This has
emulate
exposed the soil
the
surface,
natural
and
environment.
it's all susceptible to wind and
The
water
air is your
erosion.
natural filter.
On top of
Breeze
that,
caught up against these trees. and
as
it's
Harley
sediment
mentioned,
accumulating. We get
he left the
sediment
station because it's hard to make
accumulation
the living out there
happening
now.
within these channels,
Pastoralists
water
are left
back out
trying to manage this
plains.
legacy, and they have to get food on
So
offer.
imitating nature.
They have to match their carrying capacity to food on
At
offer,
a rock
and
bar
that's
across a drainage channel.
also coinciding with seasonal
Pastoralists
effects.
here have driven in
Compounding
tree
that
rods
is uncontrolled
and
grazing
as an
pressure. You've got
inverted
feral
rake,
animals moving
zip
across
structure,
the landscape, and you've got kangaroos
Come floods,
fluctuate with the
accumulated
seasons.
debris,
And
and over successive
we've
years
gone and
of
put
successive
their
floods,
water
flow
limited.
debris has slowed down
Their
water
population is
flow,
limited by
flowing
water, and we've gone and
hitting
put
still
water in
water
the
means
landscape, and
can't
we've
carry
suppressed the
sediment,
predator.
sediment is dropping
So
out.
their numbers do
Upslope
fluctuate
at this
with
rate,
the
the
seasons.
channel that was 6 foot
On
deep,
top of all that, we have our
stayed 6 foot deep.
infrastructure
Prior
problems,
to the
roads,
break
tracks,
going in.
fence
Now,
lines.
that
These are
channel's full of sediment.
altering sheep flow patterns, and this
and
is
we've seen perennial
causing
shrubs coming
vegetation
through
problems
in
as
that.
well.
From another angle, you can see the bare rock bar.
So
when the
landscapes
break was first put
function.
in.
Arid
After years, you
landscapes,
see the first flood
soil
come
moisture
through and
balance is what
accumulating
drives
debris.
terrestrial productivity.
And now,
It's not so much
this is what we've
the
got.
rainfall that's important,
You
but
look at the sediment there on the left.
it's the amount of rainfall that's important, but the amount of water within the moisture in the soil that needs to be
plants
that
growing
drives
in
the
that.
plant communities.
So,
Rangeland
moving down
ecosystems
the
are
tenure
structured
sequence into the transfer
to
zone,
conserve
sheep
scarce
wash plains.
resources
These areas are
and
in the arid
regulated
landscape,
by mechanisms
by fertile patches.
limit those water and nutrients, how they move through the
resource poor
landscapes.
into patches.
So in this photo
These
here,
fertile
a
patches function
foot-
to
a
retain
breakaway
nutrients within the
foot slope
system.
that has an erosion gully moving
If
up through it.
through overgrazing and other disturbance,
Sheep
then
flow would
these,
normally come down through,
groves
and it, has,
or
it can be
fertile
infiltrated,
patches
it'll slow
fragmented
down,
or decline,
and you get soil
then
moisture
ducted
in your
to
soils.
contain
You see the waterfall
resources,
action
and these are scarce
right
resources.
there, as the water goes over the
If they escape the
gully,
system,
it's carving, it's gaining
then you have
velocity,
a
and
decline
it's
in
taking away the
landscape
soil.
And this at a local
Water
scale
that should be
and
in
a
sheep
catchment
flow
scale
is now
has implications.
concentrated and is exiting the system, and there's no chance for
Looking at
infiltration.
natural environments, we see
Pulling the
self-healing.
plug in a bathtub.
Here where you have a fallen branch, it catches debris,
So once
and
to
sediment
address
deposition and
these sort of
colonising
issues,
plants coming.
land managers do
Inspired by
property
that,
planning
you do
workshops
such things
using their
as
land system
scrub
maps.
packing,
They can identify areas that are important to them,
dragging
high
scrub
productivity that
in
might be
over
under
the
threat, and
lip
they
of
can
the gully.
identify
You've got
the
to try and
threats
stop that gully
that
head
they've noticed
erosion.
happening.
You're still allowing water to pass
In
through
different
and
parts of
fill
the
structure,
landscape, you need different
and you're
structures
accumulating
and
seed while
techniques.
doing it. And it's holding
As
water back.
Richard's map showed earlier, picture showed earlier, very
Soil
similar.
moisture balance.
Different
Here's
techniques
a
will be
location
trialled
that
at different
scrub packing
locations
done on that
because
30
some
years
things
ago.
just won't work all
Gullies
across the landscape.
fully healed up. It
In
does
conjunction
double
with a
the grassland,
restoration strategy,
harder in a shrubland.
you need a grazing management strategy. One of the more successful ones was the Ord Regeneration Project, and this was initiated because degradation and erosion was affecting the Ord River catchment,
Moving down the,
and it was posing a
tenure
sedimentation
sequence
risk
into the alluvial
to the
plain unit
reservoir
now.
downslope.
These
involved
areas should have
deep
duplex
stocking,
soils, sandy, sand
over
over
a 30-year
harder
period,
soils.
over
Here
140,000
it's stripped
cattle
out,
removed.
water flow is moving in this direction down to a
There was
salt lake.
culling of
This is
donkeys
where you're-
between
in these sort of areas,
1979 and
you have your
1981.
wetlands,
15,000
swamps,
donkeys were killed,
player lakes
and
on the way.
it then involved cultivation and introduction of seed.
Here's the next photos you see are going to be in this part
So
of the landscape.
using that topographic catena sequence,
So on
we
the
started
ground,
upslope.
they've
And
made
this
mesh
is the same
sausages,
hills, ranges,
mesh roll,
breakaways, stony
plastic
plains,
mesh roll
low
wrapped
rises.
up around old
Ponding
scrub
banks have worked
and then
successfully
anchored
here.
down to stop them washing away.
So
And I should
the
add
scale
that
of the
scrub
problem's
packing
quite
has to be
extensive in the
to
southern
stop
rangelands.
that washing.
Ponding banks work by retaining
2
water,
years,
not damming it,
just with wind
just
blowing
holding it
debris,
back.
this-
We can
these
retain
features
water,
are
then we can
accumulated
accumulate the
a bunch of
sediment,
sand,
accumulating sediment,
and
then you
then
can capture your nutrients,
subsequent colonising
and you can
plants
regrow
came,
your plants, and
I'm gonna
improve
zoom to this
soil
area here.
moisture balance.
and then we've got perennial
Here's a
grasses
photo of
coming
where
down.
ponding banks have been on a station for 30 years. The
7
before and
years
after
later, what's
photos.
exciting is we've got
The one in
perennial
the top
shrubs
left
developing
shows a
as
channel
well
that
as
was
those,
unchanged
perennial grasses.
despite grazing and grazing strategies
Same
and
location,
de-stocking.
if
Nothing
you look
happened
upslope,
until
you
we
can
did
see
ponding
where
bank.
water's ponded.
Ponding bank allowed
and
sediment to
What
accumulate.
accumulated
and
there
then
is
the grasses
there's the
grow.
soil that's deposited, and you've
In this
got
same
perennial
landscape,
plants
this is what the
and
ponding
herbs
banks
coming,
look
and that's
like
moving
with
upslope.
introduced
So we've
grass
reinstated
over the
that
top. So
soil
the banks have
surface between the
stabilised.
banks.
It's quite a functional, productive
And perennial shrubs are
landscape
coming.
now.
Moving,
In the
continuing to
shrublands,
move
we're
down the
trialling
sequence,
ponding banks.
you get into
In
your
this
floodplain
example, you can
zones,
see
there are drainage
top
lines.
left that drainage
Nature
line
gives us plenty of examples.
that is
Again,
highly eroded. Before
natural
you can go in
filters
there and
holding
fix
up,
that drainage line,
flow,
you've got to
you
slow
get
down the
sediment
flow
accumulation,
upslope,
where you get
and that's what
sediment
these ponding banks
accumulation,
are attempting to
you
do.
get plants growing,
And
you've
after
got reeds and sedges
One thing I
here.
should say about the ponding banks is it's an exponential
Replicating that,
effect.
these pastorals here,
Usually
they
takes
put
about 8
wire
to
rolls
10 years
across their
for the
drainage
soil to
lines,
start conditioning itself.
and it's slowing
Then
flow,
you get a
you've got
sort of, by
sediment
about the 15-year
accumulation
mark, you
happening. The
start
idea
to
being,
see a good
get the
response in
sediment
plant growth.
accumulating in these
So they are a
channels,
slow
it gets the water
investment,
back out on the floodplain,
but you've got to get that conditioning process happening. So here it's only just ticking
This-
over to the
this
10-year
area, this
period, and we're starting
floodplain's
to see
a
stabilisation of the banks and slowing of the water flow through that area. This slide here shows an interesting story in that ponding banks were installed without a grazing strategy. For 15 years after they were installed, they became a preferential grazing habitat for goats. The ephemeral water that sat there for the banks was a great source of water for them, and the colonising plants that were trying to grow was a good food. It was only in the last 10 years, with the wild dogs controlling the goat population, that those banks have really taken off. The one thing that did happen in that 15-year period was sediment was accumulating, and you can see by the photos on the left that there's a lag surface when they were first put in 91, and now a lot of that lag is covered up by accumulating
This area does go
sediment.
underwater when it floods.
Within these upland environments, you have drainage channels, and again, water is moving through your landscape and slipping through your natural drainage lines. To say what Lynn said earlier, we can emulate the natural environment. Here we see a natural filter, debris caught up against these trees, and we've got sediment accumulating. If we get sediment accumulation happening within these channels, we can get water back out into the plains. So, imitating nature in this location, at a rock bar across a drainage channel, the pastoralists here have driven in drill rods to act as an inverted rake, a sieve structure, and come floods, accumulated debris, and over successive years and successive floods, those debris has slowed down water flow. Flowing water hitting still water means you can't carry sediment, and sediment is dropping out. Upslope of this rake was a channel that was 6 foot deep, and it stayed 6 foot deep until prior to the rake going in. Now that channel is full of sediment, and we're seeing perennial shrubs coming through in that. From another angle, you can see the bare rock bar when the rake was first put in. After a year, you see the first flood come through and accumulating debris. And now, this is what we've got. You look at the sediment there on the left, it's an amazing story across here. And we've got the living filter is coming, and perennial plants growing in that. So, moving down the Katina sequence into the transfer zones of the sheep wash plains, these areas are in the arid landscapes regulated by fertile patches within greater resource poor interpatches. These fertile patches function to retain the nutrients within the system. If, through overgrazing or another disturbance event, these groves or fertile patches are fragmented or decline, then there's nothing to contain the resources, and these are scarce resources, water and nutrients. If they escape from the system, then you have a declining landscape function. And this at a local scale and at a catchment scale has implications. So, looking at natural environments, we see self-healing here, where you have a fallen branch, it catches debris, and sediment deposition and colonising plants coming. Inspired by that, you do such things as scrub packing. Here that's dragging scrub in over the lip of the gully. You've got to try and stop that gully head erosion. You're still allowing water to pass through in a filter structure, and you're accumulating seed while doing it. And it's holding water back and therefore improving the soil moisture balance. Here's a location that had scrub packing done on it 30 years ago within the gullies. It's fully healed up. It does help that this is a grassland.